Hi, this is our group final project, COCO Dataset, Object Detection and Segmentation Analysis. In our project, we mainly focus on the performance of each modern object detector because they are right now widely used in our consumer markets. We will test our models on COCO dataset, and most of the related works are focusing on the speed and accuracy trade-off. There are lots of factors affecting the performance, so we will do control experiments on our models to ensure the tests are on the same dataset, size, resolution, and other trivial factors. COCO is a large-scale object detection, segmentation, and caption dataset. COCO has several features, like it has a large number of images, including over 200K labeled images, with 80 object categories.
I will introduce four models we researched: YOLO version 2, YOLO version 3, RFCN, and mask RCN. This is the graph for the accuracy and performance of the different models. The following things is the YOLO version 2 structure. And by the way, it max puts the scores in one category of firstly, and after that, the max scores in different max category will decide the result. This way greatly decrease the loss. This is the graph for YOLO version 2. And after that is YOLO version 3. It uses a similar structure as YOLO version 2. However, it simply used logistic classifiers instead of softmax in YOLO version 2. And furthermore, in the box, it concludes 3 scales, coordinators, 2 scores in one box in YOLO version 3. This makes YOLO version 3 much better. After that is RFCN. So this one uses region proposal networks for the convolution things. And for here, every 3 times 3 feature maps will conclude 1 score, and it will try to pass the threshold, which is 0.3, to decide if that is yes or no. And the last one is mask RCN. It uses a lot of 3 times 3 kernel sets and which 3 is 2 convolution layers to make sure the output is true. And all of the scores use NMS too.
We have tested sample images and get output from 3 models. Here you can see the output. Mask RCN has best performance, and performance of YOLO v3 is better than YOLO v2. Besides, we have tested the AP score for 4 models. You can see the performance result table 1 on the side. First category is AP corresponds to the average AP for LU from 0.5 to 0.95 with a step size of 0.05. AP50 is AP score on the IOU at 50. Second category is APS, APM, and APL correspond to the average AP for small, medium, and large object in the image. So we also specify the backbone network for 4 models. RFCN and mask RCN, we use ResNet 101, and YOLO v2 and YOLO v3, we use DarkNet 19. For the performance, mask RCN has the overall highest AP score, and YOLO v3 is updated version of YOLO v2, so its performance is better. We find that models are struggled when the object is small, and also the AP score decreases when the IOU threshold goes higher. For the inference time, you can see the result table. The inference time is tested based on COCO dataset and recorded the average inference time per image. So the inference time of mask RCN is the longest one among all 4 models, though it has the best performance. YOLO has much shorter inference time, and because its fast speed and concise architecture, it's widely used in industry. So for the conclusion, from previous result, we can conclude that there is a performance-speed trade-off. Higher performance comes with longer inference time. Also, we need to find out the most purple model according to the application scenario. We can also add the data augmentation before training the model, and also try to add the GAN, Generative Adversary Network, to generate more data, to deal with more messy and complicated distribution of data. And thank you.